In the previous tutorial, we implemented a Java project that has a DAO class and that connects to a database to fetch a particular record. And we've looked at how we could implement that using JDBC. We looked at all the code we need to write to implement such a method. In this tutorial, we will start to use some of the features that Spring provides to make our job easier when we talk to a database. So there are a lot of things we can do. We'll take it step by step. In this tutorial, we're going to implement a simple connection that Spring provides, and we'll look at how the connection support that's provided by Spring makes it very easy to handle the connections. So first of all, this project is not at all related to Spring. We don't have any of the Spring jars over here. So let's try to add some Spring magic here. First thing we'll do is add the Spring library. So I go to the project, properties, Java build path, and then you add library, use the library. This is the Spring library that we have configured earlier. I just select that and click finish and OK. Okay, so now I have the Spring jars added to my class path. Next step is to add the Spring XML. So I will create a new file. I'll call this spring.xml, and this will create a blank XML where I will add all the Spring configuration. I already have some configuration here, so I'll just paste it over here. Well, nothing special. The bean starting tag, and I have a couple of tags for annotation. So I have annotation config and then a component scan. Very simple. Let's say save. Now, if you notice the main, I'm creating a new JDBC DAO IMPL. Well, since we have Spring, no need to use the new, we can use dependency injection. So let's do that. This DAO IMPL is going to be a bean, a Spring bean. So I'll use the @ component tag to mark this as a Spring bean. And of course import it as a stereotype. Now, since I have used the component scan, this class is automatically going to get registered as a Spring bean with the name JDBC DAO IMPL, of course with J small case. So let's save this, and now instead of creating a new JDBC DAO IMPL, I will use the application context. So I'm picking up the Spring XML, and then I'm creating a new application context. I'll import these two. And now I can use a getBean in order to get the DAO. So I'll use this line of code, which just creates a DAO, which is a getBean of JDBC DAO IMPL, and I'm also passing the class so that I don't have to cast it. So I get a handle to an instance of this DAO class. So after that, it's straightforward. Now I can use a DAO in order to get the circle. So instead of a new class, I will use DAO.getCircle, and this should work. Let's test this out so that our Spring configuration can be verified. Well, there you go. The Spring has initialized the bean, and then I'm getting the same output. Of course, when you run this, make sure your database is running. So the dbw from the command line prompt that we had fired earlier, this is the network server that the program connects to, so make sure this server is running. Okay, so now we have added some Spring functionality, but notice all the changes that we've done is to the main. We really have not made any changes to the DAO method. With this is the problem method that we were talking about in the earlier tutorial. Now, what can we do? How can we use Spring to simplify this method? So that's going to be the next step. Now let's look at this DAO method in a little bit more detail. So what are we trying to do first? We are trying to set up a connection to the database. So connection is the first step. And then the second step is we are trying to create a prepared statement depending on the query that we are trying to run. And then the third step is actually executing the query. The fourth step is parsing through the result set to get the output or the model objects that we want. Now the first step connecting to the database, giving the database connection string, and then establishing a connection. Of course, we also have to give the driver. So this step is not going to change for different methods of the application. Most likely an application will connect to just one database. So this will come in, these 3 lines of code will probably show up in every DAO method that you would write in your program. Of course, if it's a different database, the connection string would be different, or probably the driver would be different. But then there is a limited number of databases that you would connect to as an application, and most likely it would be just one. So why do we need to keep this information in the method? Why not take this out and make it a part of the configuration? So this is going to be the first thing that we're going to address. Now this connection is a standard interface that we can use, and Spring provides some support classes that implement this connection interface, and we can use that and make it easy to configure this particular connection object. So let's have a look at that. Now if you open the Spring jar that we added to the library, there is one jar for JDBC, Org Spring Framework JDBC. So if you expand this and look into the package JDBC DataSource, there are some DataSource classes. They are the support classes. We'll pick this one, Driver Manager DataSource. So we'll use this class to configure the data source for this application, and we'll do this in the Spring XML rather than in the method itself. So I will create a new bean definition here. I'll call the ID as data source, and the class is this class, the driver manager data source. Okay, so now once I have this bean here, I can actually add configuration values to this bean. So it's just like any other Spring bean. I can add the configuration. Here the configuration happens to be the driver class and the URL itself. So I'll just paste those two here. So I'm adding configuration for what the driver class is and where the database is. So these are the two information that we need to use. We could also use the user and password if your database requires it. So this is configured as just like any other Spring bean. So now that I have this bean here, I can use this in my DAO. Instead of initializing a new data source, I can use that. So what I'll do is I'll have a member variable here, private data source. Data source is again from the SQL package, javax.sql, and I will generate the getters and setters. Okay, so now that I have this, I can actually do a auto-wired because the type, there is only one data source type. So I'll just use at auto-wired. And there you go. I have actually created a dependency, and then I'm fulfilling that dependency by making a configuration in the Spring XML. So now that this is done, I can actually use this data source in my code. Now I don't have to do this thing over here. I don't have to, specify a driver. I don't have to do this. Instead of calling a get connection from the driver manager, I do a get connection from the data source. This is the one that I have just configured, and this get connection does not take in the connection string because this is something that we already configured in the XML. Okay, so once again, to summarize, I'm using a data source bean, which is a sample data source implementation that Spring has provided. It's a support class, and we have configured the properties for the data source, which is the driver class name as well as the connection URL for the database. Second, in the DAO, I have created a data source member variable with getters and setters, and I have marked it as auto-wired so that an instance of the data source gets created and gets assigned to this DAO. And then the third, instead of getting a driver manager data source connection, what I do is I use this data source member variable, and then I do a get connection from that, and then the rest of the code remains the same. Now let's run this and see if this works. Well, there you go. It still works. So the advantage of doing this is that you have the data source specified in one location in the XML, and then you can use that wherever you want. Say you have 100 DAO objects and 100 DAO classes, then you can use a data source, just have a data source member variable and then mark it as auto-wired, and then this automatically creates an instance, and then you can use the same data source for all your DAO classes. Now this data source that I've used is a sample implementation that's provided out of the box by Spring. It's not really a very efficient implementation. It does not implement connection pooling, and what this actually does is every time you do a get connection over here, it's actually creating a new connection, which is far from ideal when you're talking about a production system. So what we can do is, instead of using the data source that's provided by Spring, we can use some of the other implementations of data source that do support pooling. So one example is the DBCP, and DBCP is a popular open source library and it implements connection pooling. So let's try implementing that over here. So in case I need to change the data source, again, the advantage of using Spring is all I need to do is modify the XML, and I do not have to change the code itself. So in order to modify the XML, the first thing I'll do is I'll retain the data source bean ID, but the class, the implementer of the data source, instead of using the Spring JDBC data source, I will use the DBCP implementation, and the implementation classes this one, org apache commons dbcp basic data source, and the properties all remain the same. We don't have to modify that. But then the advantage of using dbcp is you can add additional pooling related properties. So I can add these two lines over here which configure the initial size of the pool, which I've configured as value 2, and then the maximum active connections in the pool at any point of time, which I've configured for a value 5. So this is all it takes, at least code-wise, in order to change the data source implementation. And of course I will have to add the required libraries, and I need to add the jars which are required for DBCP. Actually, DBCP requires a couple of jars. One is the DBCP jars itself. You can go to commons.apache.org/dbcp, and then the second thing is the commons pool, which is commons.apache.org/pool, and you can of course get these by searching for DBCP and commons pool respectively. Now once you get the jars and you download them, you can add it to the project. So you say add external jars, and in my Java folder I have the commons DBCP, which is just one, add that, and then I also add the commons pooling, which is this one. So these are the two jars that you need to add. So one is the commons dbcp.jar and then the commons pool.jar. Once you add them both, you would have supplied all the required binaries, and now you can actually run this code. Now if you run this, there you go, it still works, but this time the connection source is actually from a connection pool which is managed by DBCP, and you can do this without making any changes to the code. All we have done is modified the Spring XML. So this is one of the first things that we can do to use Spring to make our DAO classes a bit simpler. So we have taken away all the connection related information in the DAO method. Now the next step we'll have a look at is the JDBC templates that's provided by Spring.